Hey everybody, in this video we are looking at example 6 in section 2, logarithmic functions of the unit on exponential and logarithmic functions, and we are just going to take a moment to analyze the relationship between the graphs of both an exponential and its inverse logarithmic function on the same rectangular coordinate system. We're going to talk about the asymptotes, the domain, the range, and then we're going to talk about dealing with that domain, what happens if you try to take the log of a negative or the log of 0, and how that corresponds to an exponential function. So let's get into it. So this first example, f of x, we said is really 2 to the x. We could also consider that as a times b to the x, 1 times 2 to the x. Our initial value is 1. That's on our y-axis. We didn't shift left or right. We went into more detail in section 1, example 1. So if you need more help, you can go, or example 2 rather, you could go there. So it's the same exact graph. Then the growth factor is 2, so 1 times 2 is 2, 2 times 2 is 4, so this is my output. 4 times 2 is 8, 8 times 2 would be 16, but that's off my graph. And then if I go left, divide by 2, I'm up 1/2 on the y value, 1/4, 1/8, and so on and so forth. So that gives me my graph of the exponential function. And I'm not going to let this curve up anything, don't do any of that. It's going flat along there, just like that. The end behavior, I got into the end behavior lingo in the other video, so go talk about that, is this horizontal asymptote. So we have a horizontal, specifically, going from left to right, like the horizon. We have a horizontal asymptote, and the equation of that will be y equals 0. Basically, it's always at y equals k, where the k is your vertical shift up or down. As for the domain of this light blue graph right over here, from left to right, is basically that we are covering all real numbers. Our domain is either, we could be writing it in interval notation, preferably negative infinity to infinity, or you can write the fancy R, meaning all real numbers. And the range, if your a value is greater than 0, if it's positive, your range is always going to be from your k value until infinity. And if your a value is less than 0, where there's a vertical reflection, your range is always going to be negative infinity until k. I'm going to erase this perhaps. Nah, I guess I'll leave it. But my range in this case will be from 0 until infinity. We use a parenthesis for the 0 because we never quite reach 0. We get closer and closer. Just like we never actually reach infinity, we will always approach it. So my actual range is that guy right there. Domain, I would prefer it written like this. Horizontal asymptote is that right there. And my function is that right there that we just graphed, right? So there we go. Now let's look at g of x. G of x being the inverse. It's exactly the inverse, so it's log base 2 of x. Now that graph is basically going to have an x-intercept of 1 the way exponential has a y-intercept of 1. And then my growth factor is 2, but it's in more of a horizontal sense, going away from the y-axis. So this is going to be 2 away, 4 away, next is 8 away, 16 away, and so on, but going down 1/2 and 1/4 away. And there you go. And that purple dotted graph is still the identity function that we mentioned before, with the equation y equals x, and these graphs should be reflections over it. So if I fold down that dotted line, they should line up, and they indeed do. What else are we looking at over here? Well, we also have a vertical asymptote, just the way we have a horizontal asymptote. So over here it is vertical, like California. We have a vertical asymptote, and the equation of all vertical lines is always x equals something. So in this case, it's x equals 0. X equals 0 is basically the y-axis. Similarly, the equation y equals 0 is the x-axis. So don't get it twisted, don't get it mixed up, right? What else is there? Basically, it's always going to be, if you know your transformations, it's going to be x equals whatever the h value is. But, you know, for this one specifically, x equals 0. As for our domain is always going to be, depending if you're lowercase b in the sense of the horizontal stretches, compressions, basically from h until infinity, or if you do a reflection horizontally, it's going to be from negative infinity until h, yada yada. In this particular case, it is going to be, not sure if you hear all the sirens, outside. Sorry. I'll be shocked if the noise canceling actually canceled that out. So you probably just heard a lot of noise. And then this is from 0 till infinity. And the range here is from negative infinity until infinity. I gotta wrap this up. Log of a negative, can I do it? No solution, my friend. And log of 0, also no solution. That's the end of this video. Sorry to cut it short. Gotta go. Gotta take a phone call. Thumbs up, thumbs down. Bye.